So we'll be looking at a number of features within Ansys Discovery, with, for example, FEA, CFD, optimization, and a bit of reverse engineering. But to start with, I'm going to start with a feature that I feel is quite often overlooked with Ansys Discovery, and that's the design abilities. A lot of you will already be using a CAD tool of some sort, and Discovery, of course, has the ability to import those CAD tools and that CAD data, and modify it and run analysis on it and explore that design. But you can also create geometry from scratch in Discovery very quickly and easily. So like an example of this, you might need to create a quick component for a particular function, and you know the basic parameters, but want to let Discovery sort of guide you on the optimal design based on the function and forces acting on your part. So what I'm going to just quickly design is a simple sort of bell crank, a simple sort of push-pull mechanism around a pivot. Obviously, because of being time limited, please don't judge me on the basicness of the design, but it should give you a good idea of how Discovery potentially can be used as a very quick and easy design exploration tool. We could then run analysis on this design that I'm going to knock up, and then we can make sure it's fit for purpose, and then we can also potentially optimize it and see what sort of potential weight savings and cost savings we can make by optimization. So we're now going to start our design. First of all, a few things to mention before we start designing. So we've got our design tab, we've got our sketch tools, and we've also got some 3D modeling tools. So you'll be familiar with a lot of these sketch tools. It is based on a direct modeling approach, but we can also turn on history tracking, which will then behave in a more parametric way, similar to your SolidWorks, your Inventor. So this will track all your changes to the model. So I've just turned that on just to show you an example of this and how it sort of works. But to start with, I'm going to start designing. I'm going to draw a line. Let's look at this from plan view. I'm going to draw this line from the center, and I'm going to type in a value. So that's going to be 200 mil. And I'm going to draw another line now from the end of this one. I'm going to give it an angle of 150, and I'll give it a length of 150 as well. So I'll type in both of those, and then I'll just join that back up here, so you can see I've drawn a fairly straightforward triangle. In Ansys Discovery, we can start to constrain our sketches. We can use our constraints and our dimension tools, and we can drive our model via dimensions. So you can add dimensions as such. So you can add all this sort of stuff in Ansys Discovery. I'm not going to focus too much on the constraints and things just for the purpose of time. So I'm just going to start designing, and then we'll go into hopefully build a 3D model. So I'm going to just draw a circle here, and on both sides I'm going to just do this as 45 mil. And then I'm going to draw, I'll say, let's say 35 mil here. Then I'm going to use my tangent line just to connect these two up. So that's going to be tangent. And I'm going to use my trim away tool just to start to get rid of any bits of curves and data that I don't need anymore. So I can start to delete stuff that I'm not interested in anymore. So you can see, just getting rid of this. You can do like sort of a box select and delete more at once. So that's my shape. I'm now going to use my create rounded corner, so I can round some corners off. I'm going to say from here to here, and I'm going to type in a value of 30. I'm going to do the same here, and do the same for these ones. So finally, I'm going to put a few circles through here, and I'm going to give those ones 30. Actually, I might go a bit smaller. Let's go 27.5. And there, let's go 20. So that's my my design, my shape. And if I'm happy with that, again, I can go along and constrain this, and then we'll be able to drive it via those constraints if we wish to make any changes, but we can always snap back to our original sketch. But I'm going to go straight into a 3D mode, which is one of these pull tools, and you can see that now my closed curves have created a surface. So the pull tool will allow me to extrude this part up or down. And remember, these same tools can be used modifying other models. So if you are bringing in your models from any other CAD system, we can use exactly the same tools here to make changes and things to your models. So all I've done is use my my pull tool just to extrude this face up. I might want to just create some sort of cut here, again, weight saving. I might think, okay, well, where's going to be the lowest area of stress? It's probably going to be in the middle somewhere. So I'm going to go back into a sketch tool and use this time my offset curve, double click here, and just create some sort of offset here. So some sort of cut. We'll round the corners off, just because we know rounded corners are better. And let's just do some nice rounds there. So this is my sort of imprint that I want to just basically cut through the part. So I go back into my 3D mode and I can slice that through. Finally, to finish this off, what I'm going to do is just make some radiuses or rads to this model. Let's add some rads to the outside. I'm going to add 5mm to those edges. You can see that, and then I'll do the same here for these internal edges. So I'm just holding control just to select all these, double clicking to get loops, and I'm going to add a 3mm rad there. So you can see I really used the pull tool and just a few sketching tools just to sort of create that shape. So this is my sort of final design. I'm not going to round off these, but you can do. Just to show you quickly the history or the feature tracking. If we show this now, you can see all of our steps taken to actually create this. So for example, the third step here, obviously the thickness is 25. If you want to change that to 30, we can type in 30 there. Go back to my last step and just rebuild the model, and the model will now update to 30mm. So I'm just going to close that. If I just do a quick measure just to show you, select these two faces, use our measure key. Shortcut is the E key on the keyboard, and we can see just very quickly that that is 30mm. So you can update your model, drive your model via your parameters in here. So that's our sort of model complete, our design complete. So hopefully you saw the speed of design there. What we can now go and do is actually run some analysis on this. We can run some simulation on this and make sure it is fit for purpose. So that's the next step. So now that we've designed our part, the next thing to do might be to simulate it, analyze it, make sure it is going to work or it is fit for purpose. So we can start to set up our simulation. So if we go now into our simulation tab, we can see we can set up a number of simulations. This one is going to be an FEA simulation, so it's going to be a structural simulation. The first thing we can do is modify our material. If we want to change our material, defaults to structural steel, but we can create or choose any material we want. I'm going to just set an aluminium, let's say T6. So I've just changed the material there. We can see all our material properties if we wish. These are all here, and we can create our own custom materials as well. If you do want access to a large, massive library of materials, you can also add that into Discovery through Granta materials. So we've set our material. Now we can start to set up our conditions. So I'm going to set a support on this axis, this cylinder here, and this is where it's going to pivot around. So this is going to be a hinged joint, so it can sort of rotate around this axis. So I'm going to accept that. I'm then going to specify a force. I'm going to apply this in this region here, and I'm going to choose a direction of this force, and I'm going to say the direction is going to be the Y direction. And I'm going to type in a force. Let's just type in a force of, I don't know, minus 500 newtons, because I want it to go in the negative direction. I want it to go down. So that's set there. Finally, I want to create a spring joint, and I'm going to just sort of create a place for this to attach to. Let's just click on my design tab. I'm going to click a point and just sort of go up from here. Again, I'm just eyeballing this, so this is where it's going to attach to. It's going to be like sort of the anchor point, and I'm just going to create a point there on top of that. So I've created my point. Go back into the simulation tab. This time we're going to actually create a spring. This is going to be attached sort of from here to oops, missed that one. There, click secondary face or secondary surface. That's going to be attached to there, and then we can specify what kind of spring it is, longitudinal, torsional, and then we can also apply a stiffness value to it. So I'm going to just apply 5,000, and we can see that be applied there. So we've now got that applied here. So now we can simulate our part. So now we can actually analyze it and get results. So because we're in the explore mode, we can get results fairly rapidly. I'm going to use the solve button here, and within a few seconds we're going to start to see results appear. So first of all, here we're looking at our displacement results. The solution is still solving at the moment, so that's now solved. We can see, hover over here, and we can see that says complete. We can see our displacement. We can view that in whatever we wish. So we can see the displacement. We can visualize this. We can animate it, so we can see that displacement on our part. If we want to look at our stress values, we can go into stress, and we're just going to hide that displacement. And we can start to see our stress values. We can start to look at this in different values. We can see our higher areas of stress. But if we want to know if this is going to fail or not, we can also go into our monitors. We can see here this has a factor of safety of 65. So it looks like it's fit for purpose. It looks like it will do its job. One thing I'm going to just quickly find out, I'm going to put a custom monitor on this part. So you can create custom monitors wherever you want to get results from this. I'm going to create a custom monitor, and the monitor that I actually want is the mass of this part. I want to know how much this part actually weighs that I've created. So I'll select the variable, click in mass, I've selected my solid, and this will just create me a monitor here. So we can see how much this weighs, 0.9 kilograms. So we can see how much this weighs. So because we've got a factor of safety of 65, obviously it is probably fit for purpose, depending on where it's meant to be used. It probably is going to be okay. We might be able to save some weight. You might be able to reduce this weight by potentially 50%, and still have a fairly high factor of safety. So the tools that we could use to potentially try and optimize our design is in the simulation tab. We have Topology Optimisation. For this to turn on, I'm just going to turn off my history tracking. So I'm just going to turn that off, and then I can click on my Topology Optimisation tool. So we're going to just optimize this part. So we're going to let the software remove mass from where is the best optimal part. But before we do that, I'm going to defeature this part. So I'm going to give it the optimal design space. So to do that, I'm going to just basically select on some of these radiuses, and I'm going to use my fill tool, which is in the design tab. And this is a great tool for defeaturing, cleaning up geometry. Discovery is another great tool for prepping your geometry for analysis. So that's another reason to use Discovery. So I'm just removing this and giving the part as much what we call design space as possible. So I've got back to sort of a fairly basic shape. And then I can go back into my simulation tab and start to look at my optimization options. So I'll just double click that. We've got our target, and I'm going to keep that as maximize stiffness. We've got our volume reduction target, and we can also add manufacturing constraints. So if you're going to mold or cast this part, if you're going to 3D print it, if you're going to machine this part, you can choose any of your manufacturing constraints here. I won't be turning it on yet, but I'm just going to leave this as a default. We do have our protected areas, which we can see highlighted sort of red. These are areas where it's not going to remove material from. You can obviously change that, and you can add any other areas protected as well. So once I've got my setup complete, I can hit the solve button, and the part will start to optimize, and we'll start to see material be removed from the part. So as it optimizes, we'll see material start to be removed from the part, and this will happen. So you can just about start to see this starting to happen now. So you can see that material being removed as it's doing its different iterations, and the material will be removed and optimized. So then we come to our sort of finished shape. Once the optimization is finished, you can use this tool here to add the optimized body to the model. So basically, this will create a faceted version of that part. So you can see here this. This might not be potentially what you want to end up with. You can always use this as a guide. You can always use this to say, where thinner areas can be, where thicker areas can be, where can I remove material from, and you can always back engineer over it. If you want to use this, you can do other things to this. We can always right click on it. One thing that you definitely probably want to do is create a validation simulation. We can smooth these facets just to make it more aesthetically pleasing, and we can also convert them to a solid. So you probably want to smooth them before converting them to a solid, and that can be exported out as any solid format. So in this instance, what I'm going to do is create a validation simulation. I'm going to right click create validation simulation, and that will do this. It looks like, obviously, for whatever reason, my spring connection has been lost, so I'm just going to just remove that and just quickly recreate that. So let's just use my spring tool. This is my first connection, this is my second connection, and just accept that. So that's my simulation done. I can now validate this, and I can obviously see if it still hits my factor of safety targets, how much mass have I reduced. So let's hit the solve button. And you'll notice, obviously, what we're doing here is actually solving on faceted data. So this isn't actually solid data, it is actually faceted data. Again, that is sort of different. Again, so we can see that we've got a factor of safety of 45.9. I think that was reduced from around 65. So decrease, which we sort of would expect because we are reducing the amount of weight. But still perfectly safe. And our mass has reduced by around half a kilogram. So if this is going to be potentially a 3D printed part, and if you can save half a kilogram per part, maybe it's low volume, but if you're saving half a kilogram, we know metal powder is expensive, then that adds up. If this is a high volume, potentially cast part, and you're producing 1 million of these, and you can save half a kilogram per part, then again, you can see where these cost savings can add up by using optimization to guide you in your design. And obviously, as mentioned, you don't have to use this exact design. You can always use this as almost like a template, and then you can design over it how you wish and let it guide you. So that's just a quick example of designing FEA and optimization in Discovery. We'll now start to look at some fluid simulations.